Okay, so hey guys, welcome back to this series where we are discussing the solutions of CodeBash. So in this video, we are going to discuss one of the most tough considered problems of CodeBash, which was string modification. So let's start with the question. So the question is, yeah. So the question is to write a program to modify a string such that the alphabets which are occurring three times consecutively in a string should be replaced by its frequency of occurrence in continuation followed by the alphabet itself. And after each modification of group of characters, add a new alphabet at the end of the string. The new alphabet which is supposed to be added at the end should be one which is successor to the last highest occurring alphabet to the whole string. A mouthful, right? So let's dissect it one by one. So we basically have to modify a string, not a problem. We've worked with strings before. So we have to check if there are alphabets in the string which are occurring three times consecutively. So this is important. And if we have in the string we have characters which are occurring three times or more than three times, then we have to replace all those things. So suppose we have three a's in our string, then we have to replace the a's. So suppose we have this, then we have to replace this with this. Basically this is what this part is, by the frequency of the occurrence in continuation followed by the alphabet itself. So the frequency followed by the alphabet itself. And so this is basically a modification. So this is basically a transformation or modification. So for each such modification, after all the characters are modified like this, you count the number of modifications, and that many characters you have to add to the end of the string. Okay. And you cannot just add any alphabets. You have to add alphabets which are successors to the highest occurring alphabet in the whole string. Okay, so let's look at an example which will make it even better to understand this. So this was our sample that we were given. So here we can see that we have these four A's and then three B's, then three C's, and then our lone wolf D over here who could not find any friends. So basically we have to replace this with 4A and replace these three B's. So basically this is our output string that we want. So we have to count the number of A's. So this is first part, to segregate the different types of characters that we have. So we have our program should be able to tell, so this is the number of A's that we have, and then to another string add the count of the characters that we have, and then the character. Then after that again we have to repeat the same process for all the characters that are there. So then again after that we have to replace the three B's by the number 3 and B, and similarly for C. And here our condition is that there should be at least three consecutive characters. So here D is alone, so we just add it as it is. And after that, so we can see here that we have three transformations over here, or three modifications that we have made to our original string. So we need to add three more characters, and not just any characters. Here we see that D is our highest character over here. So E should be a successor of D, and after that our new string is this much, and now E is the highest occurring character. So the next character whatever we add should be a successor of E. Successor of any character basically means that in the alphabet series, the next character which appears. So after D we have E, after E we have F, and after F we have G. So yeah, this is basically one of the questions which you can visualize very easily, but while you go to coding it is not that fun, right? So let's look at the pseudo code for this. Okay, So let's go to the main part where the magic happens, which is the pseudocode. So for this, we have a few variables declared over here. I is our iterator, which we use in our for loops or while loops. Count here is our variable which will store the count of occurrences, how many times each character is occurring in the string, and each character occurring consecutively. This is an important thing to note. The character should be consecutive, and initially the count should be equal to 1. So if you do not assign anything, most of the times it is a garbage value, which is not good. So we have to initialize this count to 0. Then max alphabet is the largest alphabet in our string to begin with. So basically, like we saw before, the max alphabet was D in the original string, and after that we added successors repeatedly, right? So this will be stored in max alphabet. Our output will be the output string which we are finally supposed to print, and our transformation count is basically the number of modifications or transformations that we have made. So let's start with the actual code. Yeah, and so here we have the sample so that we can take a reference from it, and we start with an output string which has an empty string in it, so nothing. So first thing is that we accept the string as an input and assign max alphabet equal to str of 0. So str is our variable which has a string over here, we are considering that, and 0 because we need to give some initial value. Okay, suppose let's say this is our initial value, so this could be the least value that we want, and after this we can compare all the other alphabets with a to check if it is maximum, so if a is maximum or the different character is maximum. Then we have a while loop, so we initiate a while loop which checks till str of I plus 1 is not equal to the null character. So remember, in every string we have a null character in the end over here, which signifies the end of the string, right? So what we are essentially doing is that we are starting from here and we are going till here. Now why I minus 1 will be clear further as we see the next steps. So again, in this outer while loop, we have another inner while loop. And what this while loop is doing is that it is counting the occurrence of each alphabet. So remember how we talked that your program should be able to segregate the different characters that we have, and then we need to count these characters. So this counting of these characters is done using this while loop. So here we are uh, basically pointing, I is pointing to this a first, so basically zeroth location of the string, and it is checking if this the character at the I plus ith position is same as that in the I plus 1th position. If that is the case, if both these characters are same, then we have consecutive characters. So if this is the case, we increment count. So we have first count was 0, then if this is same, count becomes 1, then again I moves forward. So basically, so now our I is over here, I is pointing over here, and we can see that we again have consecutive characters. So we increment our count, count becomes 2, and our I also becomes 2. So now after incrementing our I is over here. Again the same step, I becomes 2 since these two are same, and then after this we have I equal to this, and here a condition becomes false. So you can see that A is not equals to B. So we come out of the loop. But now here you can see that the value in count right now is 3, it is not 2. So we basically checked this. So 1, 2 and 3, but we also have this character that we did not take into account, so for that we need to again increment count once. So after doing that, we have the actual number of occurrences of the alphabet A in the whole string. So after that, remember how we had to check the maximum alphabet also. So basically, you can do this afterwards also, or you can just do it inside the while loop also. So we check if the string that we have at ith position. So right now our I is over here. So I'll just erase this and make it a bit clear for you all. Okay. So right now our I is over here. Okay, so we what we are checking is this. So basically in the sequence of characters, I will be at the last character of similar occurrences. So we check that if A is greater than whatever value was previously stored in max alphabet. Now, right now, since we initialized it to str of 0 means this character. So right now they are the same. So this condition would be false. But let's say I was over here, then this condition would be true, and then max alphabet will actually have the value of B. So str of I. And after that, another condition that we had was that our number of occurrences of the consecutive character should be 3 or more than 3. So here we are checking if the count was basically how many times there was consecutive arrays were occurring. So if that count is greater than 2 meaning 3 or greater than 3, then what we do, we add a string format of the count and we add stri. So str of I is basically a here. So I is pointing to the index of a over here. So str of I is a, and count is the variable count which we have which we calculated to be 4 over here, right? So after that we get this 4a, and also with this we increment the transformation count. So remember how we said that every time we change this sequence to a frequency plus character format, that is one modification or transformation, we also need to keep track of that. So that is why if we have a count greater than 3 and we know that we are adding this to our output string that we have, then obviously that is a modification. So we also increment the transformation count so that we can use it later. And if this is not the case, so we can see like in D over here it is not the case, so then we just add the character as it is to the output string. So here you can see that similar to how everything happened for A, the same process will be followed for B and C. And then after when we come to D, we realize that the count is not greater than 2, so we just add it as it is to the final thing. And after that we increment I. So basically let's say that we go through all of this for the character A, right? So now we end up with our I over here, but for the next character we need to again increment I to this, and that is why we have this increment I. And then again since this is a new character, we need to start counting from the beginning again, so we reset our count to 0. Now remember how we said that we had str of I plus 1 not equal to slash 0. So basically why this was done is because over here we are checking if str of I is equal to str of I plus 1. So if we have our I over here, we do not have anything over here to check it with. So that might throw an exception or error. So to tackle that, we said that we want str of I plus 1 to be equal to 0. So whenever we get an I, whenever our I reaches over here, we do not check anything and we jump out of the while loop. So to cover all these remaining cases, we have another while loop which goes from our current I. So okay. Yeah, so basically the condition right now is that we have gone through all of these and we have a string till this. So 4a, 3b and 3c, and our I over here is over here, so pointing at D, and it has come out of the while loop. So to tackle all the conditions after that, we have this while loop. So I again starts, we add the str of I to our output, and here also we check if this D is greater than the max alphabet. So till this substring, our max alphabet is C, but later we see that D is character which has greater importance than C, so basically higher. So that is why we need to check this again, and if it is so, then we assign it, and after that we increment I again, so I comes over here. So if we have other characters in line, we can go till the end where we encounter the /0. So now we have got a string till this, but this is not the end of the problem solution. The problem also states that we have to add characters. So we have 3 transformations here. So remember, we counted the transformations over here, so we basically have 3 transformations over here. So we need to add 3 characters over here. So to add those 3 characters, we go through another for loop with an iterator j from 1 till the transformation count, and this transformation count is inclusive. So basically the condition would be j would be equal to 1 and j would be less than or equal to the transformation count. Okay, so why 1? So we can see over here, so our output was our output string, remember. So over here we have max alphabet. So till now our max alphabet is D. So essentially what we are doing is D plus 1, D plus 2, and so I'll just write it over here. So our max alphabet is D. So in this, what we are doing, in the output we are adding D plus 1. So D plus 1 means the next character after D, which is E. Then after that we are adding D plus 2. So D plus 2 means 2 characters after D, which will give us F, which is you can see here successor of E, which is exactly what we want. And successor of F is G, which can be also be written as D plus 3. So this is why we start from 1 and we go to transformation count. So yeah, basically this was the whole logic behind it, and I know this wasn't a very easy problem to solve. So if you did solve it in the competition, kudos to you guys. And if you did not understand it, I would urge you to go through this again, and I will just revise it once more. So we start with getting the string as an input and assigning our max alphabet to our first character in the string. Then we start a while loop again, and this while loop will continue till the whatever string we have of I plus 1 is not equal to the slash or the null which is at the end of every string. So over here, so we are basically iterating from first till the second last character in the string, and for all those characters we are basically using this while loop to check the occurrence of consecutive occurrence of every alphabet that we have. So the second while loop checks the count of the consecutive alphabets, and accordingly we increment count and I. Count stores the occurrence of the character, and I is to increment the iterator. Now after this we realize that when I is over here, the condition is false, so we fail to account for the last alphabet that we have, which is why we need this increment count. After that, again we have to also check which is the maximum alphabet, so that we can use it later over here to add these characters in the end. So for that, we check if our current string that we have is greater than the max alphabet, and if we do, we assign that string to the max alphabet so that we can reset it properly. Then our condition states that we need to have at least 3 or more consecutive characters. So this is the condition which checks that, and if our count is greater than 2, then we add basically this format, which is the frequency and the character format, to our output string. And remember that this count that we have is an integer, and it needs to be converted to a string to be concatenated with another string. And we also increment the transformation count, because this is one modification and the same number of characters need to be added later. After that, and suppose that this condition is not true, that we do not have the same number of consecutive characters which are 3 and 3 or above, then we add the string as it is. So we add the character as it is. So if we had D and D over here, then we would add both of them as it is, and to the output string. And again, this whole process basically was one pass for one alphabet or character. The same thing needs to be done again for B and C and so on, for all the consecutive things. So for that, we need to increment I and set the counter back to 0 for every character that we add. Now after this, since we were only going till the second last element, we need to again consider the rest from here, for which we are using this for loop, where we simply add the string to the output, and we check if that string is greater than max alphabet. If it is, then we again reset the max alphabet to get the correct highest alphabet, and we increment I. Now we have another for loop, which is basically for the last part, which is to add the characters in the end, which would be successors of the max alphabet, which is D over here. And this D need not be at the end, it could be anywhere in the string. And so we will go to from 1 to transformation count, which is 3 over here inclusive, and we would basically take the max element and we would add 1, 2, 3 and so on till we reach our transformation count to get our final output, and we would just append it or concatenate it with our output. So yeah, this was the solution for the whole thing revised. So thank you for watching this video. Thank you for giving the competition, and hope you enjoyed it.